wabarakatuh. My name is Azizah Binti Muhammad Kasim, and today I'm going to present on my final year project 1 proposal. My supervisor name is Professor Ir Dr. Azli Abd Razak, and my co-supervisor name is Dr. Mohd Faizal Bin Mohamad. This presentation will be focused on the study performance-based design of smoke management system at UiTM SHAH Orchestra Hall. The contents of this presentation are project summary, introduction, literature review, problem statement, objective, scope and limitation of the project, methodology, preliminary results, project plan, which is my Gantt chart, and also future project planning on FYP 2. First is project summary, which is the synopsis of this project. A project study on performance-based design of smoke management system at UiTM SHAH Orchestra Hall. This is the picture of the bahagian arcade and museum, which is on renovation to make a orchestra hall of the UiTM SHAH. And my study will be focused on the smoke and heat contained in the hall during fire burning by carrying out the research on the smoke ventilation system installed to direct the smoke and hot air out of the building with presence of makeup air. The research are carried out on the simulation as to observe the smoke ventilation system will result the righteous air change and airflow with main adjusted variable of fire source location. Next is introduction. What can be defined with fire outbreak? It is a disaster caused by many factors which only requires fuel, oxygen and heat to burn. This three form also is called the fire triangle, which also known as fire diamond. How to manage the fire outbreak in a building? It is by install the smoke control system. Smoke control system is one of the fire prevention measures for buildings such as hospitals, schools, and hotels. Next, smoke control system or smoke management system are mechanical systems that control the movement of smoke during a fire. And the most common system in a building is atrium smoke exhaust system. Why building needs smoke management system? First is Malaysia has an established building code, namely Uniform Building Bylaw 1984, which is also called UBBL 1984. We comply with this code law, the building should be able to evacuate the occupants safely during fire burning. And UBBL is enforced by the local authorities and provides the minimum requirements for the Control and Construction of Street, Drainage and Building Act 1974. Second, fire safety protection system includes passive and active system. Fire safety measure, active and passive both important, which passive fire safety are required on light fire outbreak, while active fire safety are important in huge fire outbreak. One of the examples of fire safety is smoke exhaust as smoke management system on the building. Next, smoke contains various toxicity gases which can cause inhalation injury to people. Why this smoke is dangerous? The smoke itself contains toxicity gases such as carbon monoxide (CO), carbon dioxide (CO2), and many other toxic gases which can cause inhalation injury and sudden death to the inhaler. Literature review conclusions. There are several researchers that done their study regarding the smoke management system. One of the case study where the researchers studied on fire smoke control in super high halls. In their result, smoke rise quickly to 3 meters per second, which also known as chimney effect. The smoke during fire can only rise at certain height based on the power fire. It can be said when the power fire is small, the thermal buoyancy will be smaller. And my research will focus on the smoke management of the orchestra hall, where the airflow (CFM), air change (ACH), and fire source locations are taken into consideration during carry out the simulation on open form software. Problem statement of the project. Suitable exhaust fan is needed to extract smoke out of the building during the fire outbreak. The suitable exhaust fan will reduce the cost, besides will function with desired airflow CFM and air change ACH for proper smoke evacuation. Addition with that, 2 openings of fresh air intake are available at both sides of the orchestra hall as to provide adequate oxygen for hall occupants during fire burning and push up the hot air to the upper surface of the building. Hence, easier for the exhaust fan to remove the hot air and smoke out of the space. The 2 openings may worsen the fire outbreak by providing more oxygen. Thus, all these variables are taken into consideration while carrying out the simulation with various locations of fire ignition at the hall as manipulated variables. The simulation takes place on OpenFOAM software for study the smoke management of hall during combustion as to ensure all variables above will satisfy the requirement of the hall and improve the indoor air quality and save the occupants from smoke inhalation during fire occurs. To understand and plan what to achieve by the end of this project, objectives are needed. The following are the objectives of this project are to observe the smoke management system when different locations of the fire source and different airflow used. Second, to determine the suitable airflow and air ventilation to extract smoke and heat out of the orchestra hall efficiently. Scope and limitation of the project. The overall stage, audience, seat and interior space of the orchestra hall is the actual place to carry out in the simulations. The dimension is based on the actual design and few number of samples will be tested by manipulating the variable in the simulations. Third, there are 3 number of variables which are opening of fresh intake for both sides of the building, exhaust air grill and the locations of the fire source. Fourth, the simulation is carried out in OpenFOAM for combustion analysis, which is the OpenFOAM software is downloaded at openfoam.com for Windows 10. Methodology. Simulation analysis flow contains 3 phases, which are Phase 1 design, Phase 2 block mesh and Phase 3 product. For the Phase 1 design, the machining design of the orchestra hall based on the original dimension in CATIA software. Whole space are drawn in simplest form for smooth simulation on OpenFOAM. Phase 2, block mesh. The design from CATIA software then are meshed into the OpenFOAM for validating before simulation are carried out. The block meshing is carried out for the same design outcomes that has been drawn in CATIA software before as to carry out the original dimension during the simulation. Phase 3, product. The product obtained at the end of the simulation are the value of the air change ACH, airflow CFM based on the multiple fire sources location at the orchestra hall. These are the preliminary results of this project, which is for the figure 1, side view of the orchestra hall, figure 2, front view of the orchestra hall, figure 3, isometric view of the orchestra hall, and figure 4, top view of the orchestra hall. As you can see, this drawing is drawn at CATIA software, and there are few stages on this drawing for the audience stage and also the stage for the performing, and also there are written air grill at the top of the orchestra hall and 2 exhaust air grill at the both sides of the orchestra hall. These are the preliminary results from the OpenFOAM software, which is as panel can see, figure 5, the preview of the STL drawing of the orchestra hall, and also figure 6, the wireframe view of the orchestra hall at the OpenFOAM software. Block mesh in OpenFOAM. The block mesh process is carried out to check the simulation domain and simulation setup before carry out the analysis of the combustion in OpenFOAM. To obtain the preliminary result on this project, there are few procedures to be followed. First, The drawing from the CATIA is compulsory in IGS format, where this IGS format is used as for open form read for carry out the mesh. Second, IGS file is open at Paraform to see the dimension enter can be used or not. This is because OpenForm only can read the dimension in meter. Third, the mesh from the closed region at the wireframe view can be combined with Paraview of STL drawing but needs height graphic for the combinations. Fourth, for the Paraform coding from the tutorial, it shows that the dimension from the STL drawing needs to be same as for generate the drawing at OpenForm. Then it can be analyzed at the Paraform. The Paraform can be defined as a software to read the file from the OpenForm, and OpenForm use terminal in CPP program. The project study plan Gantt chart of this proposal, which contains activities and also 14 weeks to complete this project proposal. Future project planning is a plan on what to do in my final year project 2 on next semester of this project. First is to carry out the combustion simulation of the orchestra hall on OpenForm software with various of the fire source location as to observe the smoke management of the orchestra hall. Second, to find the best airflow CSM and air change ACH during fire burning and satisfy the manipulated variable of time consuming during fire outbreak and fire source location by calculation and also simulation on OpenForm software. That is all from me, and thank you for your time spent for watching this video. Have a nice day and Assalamualaikum warahmatullahi wabarakatuh.